All right, here we are for 3.2, where we're finally going to get to radians, the other angle measurement. And we're going to do it by starting with this little demo here. So, you could notice, and someone certainly noticed and thought it was worth noticing once upon a time, that, notice we're not in the XY plane here at all. We just have, there's no x-axis, it's just an angle, and we have a circle here. So if we have an angle at a circle like this is called a central angle because the vertex of the angle is at the center of the circle. The way the measurements are going up here right now, our radius, A to B, distance from A to B, 6.24 centimeters. Another quantity, another length you could measure is on this circular arc from B to D, all right, this distance right here. And right now, the way things are positioned, 3.78 is the length of this arc. Now, if you let your angle get a lot bigger, well, okay, the radius isn't changing, we're just making a bigger angle on the same circle. But that arc certainly gets bigger as your angle gets bigger. Now it's 15.21. But over here, we had an arc length measurement that was smaller than the radius. And if you go, if you go far enough, you definitely get an arc length measurement that's more than the radius. So you could ask that question about where that magic point is. How big is this angle when, I got it. When the length of the radius and the length of this arc are exactly the same. All right, that can only happen for one particular angle measurement, and it doesn't even depend on what circle you're talking about. If you change the size of the radius, you'll change the size of the arc length, but there's some magic angle where the arc length is the same as the radius, and that angle measure is called 1 radian. This is the definition of what 1 radian is. We defined a degree just by saying, well, we got a circle and we'll just chop it into 360 equal pieces. That's what 1 degree is. Radian has a very different sort of definition, but it's the angle at which the length of the arc between the two sides of the angle is the same as the radius. And it looks like it's about 57.28 degrees, so it's not like some very nice angle measurement. It's a little smaller than 60, but that's what 1 radian is. That's our definition. And if you define that to be 1 radian, then you can measure any old angle using that as your unit of measurement. So on the 3.2 notes, filling some things in, we start off with the definition that we just talked about. All right, so here's the picture. The angle you get when this arc is r, matching the radius r, that's 1 radian. And for any other angle then, the way the measurement would work out is that you just do a ratio of whatever this arc length is and divide it by the radius. So when s is equal to the radius, you get 1 radian. When s is smaller than r, bigger than r, you get different angle measurements. But that's what, or how a radian is defined. Now, ultimately, we then need to get to the question of, well, how do you go back and forth between radians and degrees? All right. So this is just reiterating what the second picture says. S over r is the measurement in radians for an angle. Now, in terms of just little notational things, when we have angle measured in degrees, we put the little circle there in order to show that we're measuring in degrees. All right. So yes, here's our little degree mark. For radians, we typically, sometimes we'll write rad after it. All right, you might write 12 rad. But if we say an angle just has a measure of 12 and we don't put any unit after it, the assumption is that we're talking about radians. All right. So how do we get back and forth between these guys? Now we know there's 360 degrees in a whole entire circle. Well, how many radians are in a whole entire circle? If we knew that, we would we'd have our measurement. So this little picture sort of shows you how radians fit into a circle. So you get a radian when, so here's our radius, which in this picture is 5.9. And you get another radian every time your arc length on the circle is equal to that radius. So here's 1 radian when we go 5.9 centimeters. If you go another 5.9, that'd be 2 radians. And then 5.9, 5.9, 5.9, 5.9. Now that's 6 whole radians by the time you get to point n, and then there's this little bit left over. So we don't have a nice integer number of radians fitting into a whole circle. In fact, what we do know is the distance all the way around the circle, the circumference, we know the formula for that. It's 2 pi r, 2 times pi times the radius. So in fact, how many radians are there? Well, when you get r units for every one of these chunks, you get 1, 2, 3, 4, 5, 6 r's plus a little more. In particular, though, all the way around, it's 2 pi r. So really, it's 2 pi radians all the way around the circle. And that allows us to come up with conversions between things. So full rotation has 360 degrees, like we said. And this stuff over here is basically what we were just talking about on that little demo. So there's 2 pi radians all the way around. So in other words, 360 degrees and 2 pi radians are the same thing. So 1 degree, if we divide both sides by 360 and cancel a little bit, is pi over 180 radians. Or 1 radian is equal to 180 divided by pi in degrees. And in fact, if you punch that out, you'll get that 57.28 number that we saw earlier. Now, this is not what you should remember. This is what you should remember. 180 over pi, or pi over 180. All right, so going degrees to radians, multiply by pi over 180. That's this. Other way around, multiply by 180 over pi. And it basically comes from the fact, well, 360 degrees is 2 pi. Well, if you divide both sides by 2, 180 degrees is equal to exactly pi radians. So doing conversions, it's just a matter of keeping things straight. And oftentimes, when we state angle measurements in radians, we state them as fractions of pi. All of our nice common angles like 30, 45, 60, 90, etc. are equal to some nice fraction of pi. And here's just a few of those. All right, so for example, 90 degrees. Well, to turn that into radians, multiply by pi radians over 180 degrees, basically. So the degrees cancel and our result is in radians. If you simplify, you get pi over 2. Likewise, 240 is 4 pi over 3. Pi over 6, all right, is a measurement in radians. And if you multiply by 180 over pi, the pi's cancel, and we just get a nice 30 degrees like so. And you can see a similar sort of thing happening for 7 pi over 4. All right, so on the next page, just a bunch of examples to try. And I don't think I even need to necessarily go over those in the video. Convert degrees to radians, etc. It's worth pointing out on the next page, the last couple don't give you very nice answers. Some people get stuck in the fact and think that every time you have an angle measurement in radians, there has to be a pi involved. But no, there doesn't. Right? You can have an angle measurement which is 1 radian or 4.3 radians or something. There doesn't have to be a pi in there. But all of our nice typical angles do or can be written as a fraction of pi, and so that's what we often do. All right, on the back though, try some conversions. Punch out all your answers in terms of decimals. All right, your radian measurements, many of them can be written as a nice fraction, but also as a decimal, and you'll see that in the notes. And then at the end, the point is simply to compute some trig values for angle measurements that are in radians. Now, your calculator can handle radians if you put it in radian mode, and you're careful about how you punch things in. But also, every angle in radians is equivalent to some angle in degrees, and the examples at the bottom of the next page are all examples that angle measures in radians that correspond to nice angles in degrees. So you could convert them over and then figure out what they are. Or really, just get your calculator out, put it in radian mode, and punch things out. And when you see 0.866, remember that's square root of 3 over 2. And when you see 0.707, that's the square root of 2 over 2. And you should recognize 1/2 when it pops up, and so on. All right, this was a short section. That's pretty much all there is to say. 3.3 won't be real long either, but then we'll get to some more substantial stuff in 3.4 and 3.5.